Okay, so this is the lesson 8 homework help for what does it mean as part of unit 1. So we're going to start off with number 1, which is really just asking us to categorically sort of differentiate between arithmetic and geometric sequences using this Venn diagram. So use the Venn diagram to compare and contrast arithmetic and geometric sequences. So the first thing, right, Venn diagrams, the portion in the middle is what they have in common. So, think about what they have in common. I would say that they both have some sort of initial value. So, we'll write that. They both have, oh, see if we can write on the board. They both have initial values. Uh, and they also both can be represented in a bunch of different ways. Like we could do it graphically, we could do it with we could do it graphically. We could do it in groups of like dots. Let's say we could do it with their different equations, right? So there are multiple ways to represent each. So multiple representations. And we'll just leave it as reps for right now, but representations. Now let's look at arithmetic. All right, so what is a characteristic of arithmetic sequences that's not a feature or characteristic of geometric? Well, arithmetic is always going to have a common what? A common difference, we call it, right? Which means that each step is the same value. So that's going to be addition and subtraction. Oh, it didn't write for me. There we go. Addition or subtraction. There we go. And likewise, geometric sequences have a common something, but that's not a common difference. It is a common ratio. So, oh, it didn't write for me there. Ratio. So that means that from step to step, instead of adding or subtracting the same thing, we are multiplying or dividing the same thing. So we'll put a little x here and then our division sign here. So those are the operations used in arithmetic and geometric sequences. All right, so we'll move on to number 2. I believe we're doing 1 through 6 and then number 10. So here we go. All right, for each representation in problems 2 and 3, select all items that connect to it. So here are our items, A, B, C, D, E, F. But unfortunately, problems 2 and 3 are on the next page. So we're going to move over to be able to see 2 and 3, and we'll come back and visit. All right, so 2 has 1, 2, 3, and 4 items, and they go from -10 to -20, -30, -40. So to me, that means it is arithmetic because we're jumping by 10 each time. We're sort of subtracting 10. But let's go over and see which ones show arithmetic and subtracting 10 and all that. So right off the bat, we'll do this one in green. So this looks arithmetic to me since it's a straight line. That would be D looks arithmetic to me. A does not look arithmetic at all, right? Because it has this exponent with the t. It's 122 times 1.02 to the t. So that exponent t, that looks very geometric to me. So that's not going to be it. Each day, Alex is borrowing $10 from his mom. Okay, so he could have taken $10 the first day, $10 the second. So that would make sense. So we'll go with B as well. Let's look at C. C has -10 -10 to the or times n-1. So that is the explicit form is starts at -10 and we take away 10 each time. That could be it. Yeah, so let's go with that. So we've got D, B, and C are definitely related. E, it's curved, so it's not going to be that one. And this table, well, we already saw the table from the other one, so it can't be a table because those tables don't match up. So B, C, and D. All right, so we're going to go back up. B, C, and D are our answers here. B, C, and D. All right, and now let's go look at number 3. Jose is studying the growth of the economy, and he believes that the rate of growth will be 2% for the next several years. If it has a current value of 22 trillion, how many years will it take to double the value? Oh my, okay. So key things to look at here will actually we'll switch this black pen back to purple because we like working in purple. So at the rate growth will be 2%. So 2% is going to be important. We can think about 2% increase, right? The rate of growth, that's going to be equivalent to 1.02, right? Because if we multiply by 1.02, that's increasing by 2%. So we're looking for like 1.02s in there, and it has a current value of 22 trillion. So let's go and look. All right. Well, our 22 trillion happens right here, and the 1.02 happens here. So it's definitely going to be A. That definitely has to do with this situation. E, that looks like it crosses at 22. And the curve gives us the geometric sort of feeling and look to it. So E is going to be related. And then F, well, I don't know what, right, notice here that it starts at 5. So we don't know what 1, 2, 3, and 4 are, but it looks like the growth is jumping. It's a little bit bigger each time, right? So this jump was a little bit less than 0.5, right? And this jump was a little bit more than 0.5, right? We can see that. So this is, we'll say that this is less than 0.5, and this one is more than 0.5. So the jumps are not all the same size, which means that this is also going to be geometric. All right, so A, E, and F, that's what we're looking at here. Let's go back over. All right, A, didn't like that one. Here we go. A, E, and F. Okay. Now let's move on to number 4. Each of the tables given represents an arithmetic sequence. Okay, so it's telling us right off the bat, arithmetic sequence. That's good. Find the missing terms in the sequence, show your method, and create the explicit and recursive equations. Okay, so we're only dealing with arithmetic here, which is good. Because in arithmetic, we know we're going to add the same thing. So we know that whatever our step is here, we're going to have the same step here. Oh, it did not like that one. Here we go. Let's try that one again. Right, so we're going to have the same step each time. So if we're stepping from 3 to 12, we know the whole thing is going to be 9, right? If the whole step is 9, that means that each half step must be half of 9. So 9 divided by 2, right? 9 divided by 2 is equal to 4.5. Right? So 4.5 is what we got. So if we jump up 4.5, really didn't like that, from 3, we're going to end up at 7.5. 7.5. And then if we jump up 4.5 from there, we will end up at 12, so that works. All right, so let's write our explicit now. What do we like for explicit? Let's say f of n. Oh, that looks like n prime. We won't get to that yet. That's more of like calculus stuff. F of n equals, and there are 2 ways to write this. We'll write both here. So the first one would be, we'll have our starting value, which is 3, times, let's not do that. Let's first write, what would our starting value be? Well, we know that 1 goes to 3, but our jump is 4.5 each time. So 4.5 is our jump, so 4.5n. And then if we were to plug in 1, we should get 3. So if we plug in 1 for n, we'd have 4.5. So we have to actually take away 1.5, minus 1.5. Right? So that looks good to me. 4.5n minus 1.5. So that's good. And recursive will say that whatever our current step is, right, it's going to equal f of, didn't like that one. It's going to equal the previous step, or f of n minus 1, f of n minus 1. It's going to equal f of n minus 1 minus, no, not minus, sorry, we're jumping up by 4.5. So it's going to equal the previous plus 4.5. And then we should note that f of 1, right? If we plug in 1, what do we get? That's 3. Okay, so that's our first question out of the way. And it looks like 5A, or sorry, question 5 goes on to the next page. So I have copied it up at the top of the next page. There we go. Here's our 5 circled. So we've got question 5. Let's do that now. All right, remembering we are still doing arithmetic sequences. So we know that there's 2 jumps. So from here, right, from 2 all the way to 26 is a plus 24. But we have 2 now intermediate steps, right? 1 step, another step, and then the final step. So we have 24 is the total jump, but we have to break it up into 3 little steps. So 24 divided by 3 means that each step is 8. All right, so if we jump up 8 from 2, we'd get to 10. If we jump up 8 from 10, we'd get to 18. And if we jump up 8 from 18, we'll get to 26. So that's perfect. All right, so our jump is 8. And let's go to our explicit now. All right, explicit, we have our function of n, where we jump up 8 every time n increases, so 8n. And then where do we start off? Well, if we plug in a 1, we need to get 2. Normally, if we plug in 1 right now, we'll get 8. So we have to take away 6, so minus 6. All right, and then recursive, f of n, right? Our current step equals the previous step, f of n minus 1. F of n minus 1 plus, what are we doing each time? We are adding 8. Plus 8, there we go. So that is our recursive for number 5. Number 6 now, still doing arithmetic, right? We expect that, but now it looks like we're going down, right? So our big jump here is, it looks like it's down 24 to get to 0, and then down 3 more, so down 27, so minus 27. All right, and we've got some intermediate steps though. There's some step here, another step here, and a third step here. All right, so our 3 steps need to be a total of minus 27. So we would do minus 27 divided by 3. And if anybody recognizes 27 divided by 3 is 9, but it needs to be negative, so negative 9. All right, so we get negative 9 each jump, so minus 9, and minus 9. All right, so if we have 24 and we take away 9, what do we get? If you said 15, you're right on. So we get 15. We take away 9 again, we'll end up with 6. And then if we take away 9 from that, we get negative 3. All right, so our explicit function here, right, f of n equals, now our jump is minus 9 each time, so negative 9n. And now, what are we starting out with? Well, if we plug in a 1, we'll get negative 9. So we actually need to be at 24, so we have to add the 9 back to get to 0, and then another 24 to get to 24. So 9 plus 24, right? We can do that over here, right? 9 plus 24, that's what we would need to start at. That needs to be our starting value. So looks like that's going to be 33, and that kind of connected. So let me just to be very clear, right? This was equals 33. Okay, so we need plus 33 as part of our explicit here. All right, and now recursive. I think this one's a little bit more straightforward. You just need more information, or you need sort of 2 equations. So f of n equals, oh, there go the lights. One moment, it's not as bright out, so We will get the lights turned back on. Excellent. All right, we're back. So our current step is our previous f of n minus 1. F of n minus 1. And then what are we doing each time? We are subtracting 9 each time. And then we are, that's all we need, right? Is take the previous step and take away 9. But then we need to know that the one step we do know is that f of 1 equals 24. Right? Okay, and we are done with number 6. All right, last one in this assignment is number 10. So we actually have to skip all the way over, but let's read the instructions. Identify the type of sequence and then determine the recursive and explicit equations for each sequence. If the sequence is not arithmetic or geometric, identify it as neither and don't write the equation. So we do have to consider now that the sequence of numbers might not be arithmetic or geometric. So we'll keep that in mind. So identify the type of sequence is going to happen. And then determine, all right, so we're going to need type of sequence, recursive, and explicit. Okay. And then keep in mind if it's neither, we can write neither. All right, let's go look at number 10. All right, this is our last one. All right, so 60, 30, 15, 15 over 2. All right, there are two things that pop out at me immediately. One is that I know that like 60 to 30 is cut in half, 30 to 15 is cut in half, but I also see that this 15 to 15 over 2, I mean, that is like this 2 in the denominator and the same numerator just absolutely jumps out at me as being, oh, that is cutting in half. Right, that has to be dividing by 2, multiplying by 1/2. So if it's that, right, same multiply by 0.5, we know that's going to be geometric. And now we just have to write the equation. So let's start with recursive, since recursive is up first. So function of n equals the function of n minus 1. And then what are we doing each time? Well, we're taking the previous step and we are multiplying it by 1/2. And then the first number in our sequence are 60. Well, the first number is just 60. So there we go. So that is our recursive equation done. And now our explicit equation, f of n equals, well, again, there are two ways to write this. We'll see if we can write both this time. So the first is to say, oh, it wouldn't be an f. What am I doing here? Not an f there. Sorry, the first is going to be, oh, we're going to take n. Nope, not take n. What am I talking about? We are going to take 60, right? 60 is our starting point. And we're going to multiply it by 1/2 to the n. 1/2 to the n. But when we do this, this would actually make our starting value, because we said that if we plug in 1, right, we said our first value is 60. So if we plug in a 1 for n, this would actually become 1/2 to the 1, which is just 1/2. And then multiply that by 60, that would actually make our starting value 30. So we need to make our high up, right, our exponent n minus 1. So we have to do that. That's one way of writing it. Another way of writing it is to say, okay, and these are equivalent, we would say f of n equals, and then we would actually just double the 60, since we know that 60 times 1/2, right, we have to like undo the 1/2 a little bit. So we could actually write it as f of n equals 120 times 1/2 to the n. Oh. Now, these two equations are the same, right? They look different, right, but they are equal. So they would both be Acceptable explicit equations, right? If you have either one of these written, that will work. They are both explicit equations for this same sequence. So a good thing to note. And that wraps up this homework.